Before we take a few notes, if you have not checked the answer key from last night's exploration, please make sure you do that. In particular, look over the question number 5 that asks you to transform that Cartesian form. So yesterday we were transforming back and forth between polar and Cartesian form, working with equations. Today we're going to look just at coordinates, how to switch from, its Cartesian name xy to its equivalent location, but its polar name r theta. So we'll try 2 examples of that, and then you have a little bit of practice you can do on your own. You should submit a picture of your work to Schoology. Okay, so here's example 1. Get your notes out, ready to go. We are going to convert from polar to Cartesian this time. So the polar coordinates of a point we're going to use 6 120 degrees. So we would rotate 120 degrees, go 6 units in that direction. Let's find the equivalent Cartesian coordinates. The diagram is everything for these. That's what's going to let us kind of put all the pieces together and connect the 2 forms. So let's first sketch what 6 120 look like. I've got my coordinate plane. I'm going to just estimate where 120 degrees is. I'll make that a little straighter. Let's say right here. And we're calling this length 6 units long. Okay, so that point that we just drew, that is the point 6, 120. What we want to find is, what's its other name? So instead of traveling, could I go left units and up y units and figure out how to get to that point as well? Now this one, if you remember, 120 is sort of a special angle because its reference angle is 60 degrees. So we're really looking at a 30, 60, 90. So here's option 1. You could realize, oh, that's a 30, 60, 90. That side relationship is 1, 2, square root of 3. This is the hypotenuse of 6, so my short leg is 3, but that is in the negative direction, so I'm going to make that negative 3. And then the longer leg is 3. That's option 1, so that is if you realize that that's a special right triangle and you remember those side lengths. However, maybe one of those is not true. Maybe we don't know, we don't recognize that that's a special right triangle, or remember the side lengths, or it's not a special right triangle and you can't use that approach. If that was 127 degrees, we're stuck. That is not the option. However, we have these 2 equations from yesterday. X is equal to r times cosine of theta, and y is equal to r times sine of theta. Well, we have r and we have theta. Let's just plug them in. This direction that we're going from polar to Cartesian is the easy way because you have these equations that let us just boop, plug them in and we're done. So this would be 6 times cosine of 120. I mean, honestly, you could put that right in the calculator. It will even correct the sign for you, the plus or minus sign. That's negative 3. 6 times sine of 120 for our y value. Now, the calculator is not going to give you an exact value, so that's where we could be locked in on what method we have to use. If it says find the exact Cartesian coordinates, the exact value, then you really have to use the special right triangles. The calculator is going to give you about 5.2, but that is 3 times the square root of 3. So if there's no specification, or again, maybe it's not a special right triangle, you're going to use these 2 equations to help you. So the coordinates are, let's make sure we have a final answer here. Our x value is negative 3. Our y value, we'll use the exact one, is 3 times the square root of 3. Okay, and again, that's the easier method because we just have r and theta, and we have these equations that do all of that for us. Okay, going the other way, maybe takes a little more thought. Let's try example 2. So this time we are given Cartesian coordinates, or you're going to see the book using the term rectangular coordinates. We talked about that a couple days ago. That's the same terminology, really. The rectangular coordinates, I'm just going to abbreviate here. Rectangular coordinates of, let's use, these numbers should sort of stand out to you. -2 times the square root of 3. Yeah, there's a decimal approximation for that, but I'm going to leave it like that, comma, -2. Let's convert to polar coordinates. Again, the diagram is everything. Let's get those in there. We're going to pay extra close attention to the plus or minus signs. So -2 root 3, whatever length you want. Let's label those. Now, again, maybe you realize that's a 30, 60, 90. So if that's the case, I don't think this is any easier or harder than the last one. If you realize, wait a minute, these side lengths are the relationship that we need in a 30, 60, 90, where we've got a short leg and then that number times the square root of 3. This is option 1. Know that that's a 30, 60, 90. Find the hypotenuse. That would be twice as big as the short leg. 4, right? This would be 4 here. And then theta, now be careful. So we can find the reference angle inside the triangle. Now across from that is -2. So that's the shorter side. That means that that reference angle, I'm going to label it this way, is 30 degrees. But actual theta is another 180 degrees tacked onto that. So 210 degrees. So here's option 1. You realize what kind of special right triangle that is, or you at least have that option. You fill in the missing pieces that way. Or option 2, let's think about what those equations can do for us. Now, what we're trying to find, let me change my diagram real quick. Pretend we don't know these yet. And we need to find r and theta, or because we're working in the triangle, we're really going to try to find that reference angle first and then just tack on 180 to it. We have x and y. So remember, we have this equation. Let's just do some right triangle trig here and some little Pythagorean theorem to find some missing parts. So we could do this. X squared plus y squared equals r squared. Watch your plus or minus signs. I'm going to do x squared plus y squared. Looks like that. Equals r squared, and just solve for r. Your calculator could probably do a lot of the work for you, but let's see. -2 squared is 4. This would be, okay, a -2 times a -2, which is 4, and then times just a plain old 3, because the squared and the square root would cancel each other out. That's r squared. So r squared is equal to 16. So r is equal to, remember, we don't need the plus or minus because it's just a length, so r is equal to 4. So that's not too bad. That equation will do some work for you. Then we need to figure out how to find theta, and let's think about the reference angle. Well, that's just a right triangle. How about a little bit of SOHCAHTOA? We have some options now. If you're really confident with your r value, you have sine, cosine, or tangent that you could use. I think it's always wise to use the info given to you. So if we have this theta value, this is my opposite. This is my adjacent. I'm going to use -2 over -2 root 3, and then we'll really let the calculator do the work for us for this one. So the reference angle would be equal to inverse tangent of that ratio. You could lose the negative signs here if you wanted. So the reference angle is 30 degrees. But we want, and we could actually use arctangent, and it would kind of prompt us to find this theta value anyways, but really we just need to, if you have the diagram, you're just adding 180 to that. So 30 plus 180. Remember, that's the number, the angle measure we got earlier as well, right? So this is still, final answer here. R is 4, theta is 210 degrees. I'm going to ask you to practice. There's, I think, 4 of each. 4 that start in Cartesian and go to polar, and then 4 that go the other way around. You have to diagram for these. It's going to kind of let you know, okay, is this a special right triangle? Can I find some missing measures? What quadrant do I need to be in? Okay, so start with those diagrams for each of them, and then you can decide what method you're going to use, right? Please don't forget to submit a picture of this on Schoology. Let me know if you have any questions. Thanks, everybody.